divided by 2, 65. So if you told the guy you can expect to make around 65 million, that's the median income. Okay, cool. What's the average of these? 170, 670 divided by 4 is almost 170, whatever the hell it is, 168,000. Who's got? Is anybody helping me out? Nobody's helping me out. This is all watching. Come on, math boy. Right, so if I told him you'd expect to make, I think it's about 168. 167.5. That's close. So 167.5. So you expect 167,000. That's just lying. I mean, that's. You might say, well, that's the average. Well, no, that's not representative. In that case, I want to use the median. Same thing with home prices, especially here in California. You know, 300,000 somewhere is the median, but how high do they get? Well, how much money exists, right? I mean, you see some of these places. All right, there's 4 million, 5 million. There's 10 million. What? Okay, that's nice. Let me just walk in there once. That's about it. So it's close to all I get. But you guys get the idea, right? I mean, that's pretty straightforward. That's why there's so many different ways to measure center, because it depends on the situation which one's better. Here's another way to measure center. And we already have kind of seen this one, in a way. It has to do with how data clusters, and it's called the mode. So you got mean, median, and the mode. Data value that occurs the most. Right, so I could have a situation where if my data list looked like 2, 5, 7, 11, what's the mode? There is no mode. Okay, 11. There is no student. No mode. Nobody gets my matrix. So what if it was 2, 5, 5, 11? Incredibly enough, the mode would be neither. Right. All right, what if it was 2, 2, 5, 5, 11, 11, 11? Yeah, there's a clear winner, right? The mode is the one that occurs the most. So the mode here is 11. All right, what if it was 2, 5, 5, 11, 11? 5 and 11? 5 and 11. It's bimodal. Right? Don't judge. It's just got 2 modes. Now this book, personally I was taught, and I agree with the fact that if there's more than 2 modes, there really is no mode. I want to figure out, where do people hang out? Where does this data tend to hang out? Where does it cluster? If it's clustering in more than a couple places, there's not really somewhere it tends to go. You understand what I'm saying? So I figure out, where do people normally go here? Well, there's 5 different places they go. There's not really somewhere they tend to go, right? But this book does go over trimodal, multimodal,
a million
right?
points, a million data values.
Yeah. So you can go multimodal. Personally, I would say that if there's more than 2 modes, there really is no mode then, because it's not really clustering in certain places then. You can do it either way. You can do, as the book says, multimodal. Cool. Does that make sense? Is that cool? Something we've done that kind of shows us this really quickly is a dot plot. Doesn't it show me where things are clustering? Repeated value, so it is sort of like showing me the modes. Okay. All right, and this one is kind of weird for when it's the best. A situation where it's clearly the best is if my data is not even numerical. So if I went out and just started recording the names of cars that I see in a parking lot, well, if I write Ford most, that's the mode. Ford is the most occurring type of car. So the mode can be used for non-numerical data. That's actually when it's most immediately useful, right? Because you really can't take an average name of car. The average name of the car is I don't know what that means. All right. One last measure of center. Oh, yeah.
Is there a symbol for mode?
Not really. There's not an accepted symbol. We can make one up if you wanted to. symbol that Prince used when he changed the name? Or no, but it's not really a symbol for method. Yeah. One last thing, if I remember correctly, is mid-range. It's exactly what it sounds like. So let me see if you guys can figure this out on your own here. So if I give you some data, 11, 12, 17, blah, 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 and the highest one was 81. How do you think you'd figure out the mid-range?
81.
That would be the range, right? The range would be 81 minus 11. I want the mid-range. I want the number in the middle of the range. Add what up? Not all the numbers, that would be the average. So the mid-range is high plus low divided by 2. So it would be 81 plus 11. How do you find the middle of any two numbers? Add them up, divide them, take the average. That's how you find the middle of any two numbers. So all the mid-range is the middle of the range. What screws people up is range is high minus low. So I always see a minus in this equation, which makes no sense. Because to find an average, I have to add, right? Thank God that I let you make a formula sheet for a test. So 81 plus 11 is 92, divided by 2 is 46. Cool. Okay, let me see. Make sure I don't leave anybody out here. Yeah, okay. One last thing in this section 3.2, and I want to give you a little preview of the next section. That distribution, who knows what I can say about that distribution?
It's normal.
It's bell-shaped, so it's normal. There's one thing you can say about it. It starts low, goes high, goes back to low. So the idea of normality is important in everyday life, but it's also important in statistics, because the more normal a distribution is, I've got a very set, prescribed method of things to do with it. Right? So I want to kind of know when is something normal enough for me to attack. It's also symmetric, which is kind of like a part of what normal is. Normal's got to be symmetric, bell-shaped, right? But you can have a symmetric distribution that's not bell-shaped. Like this is symmetric also. If I just go, woo, woo. I mean, that's symmetric too, right? Okay. What about something like this here? Is that normal? No. That would be skewed. And in fact, skewed into which direction do you think? Skewed to the right. To the right, to the right. And what about, of course, incredibly enough, I can draw another picture, but I think you can imagine what it would be if it was skewed to the left. Just wherever the tail is, right? So that doesn't mean like badly skewed, like I picked a bad sample. It just means the distribution happens to be skewed in one direction or the other. All right, so a little preview of the next section. And the next section is actually probably the most important section we've hit so far. It's coming up. This next, oh crap, I'm like right on the camera. It's like it's just me, Jeff's shirt. Yeah, this is exciting. The next section introduces the idea of, on top of the idea of center of data, how spread out my data is. So we already have this idea of range, which the very first thing I'm going to do next time is show you that range is not good enough. It doesn't distinguish well enough between data sets. So let me give you this scenario. You guys all know about like ratemyprofessors.com, right? If you haven't heard of it, you can go there, there's reviews. And I remember, I can tell you some stories about them anyway. There's another website that I'm not going to tell you what it's called. You can actually go to and find all the grade distributions for every teacher, for every class they've taught. So, sounds interesting. You have to pay for it now, so that's a good thing. It used to be free, so you missed out. So let's say you knew that you had to take this course, and these two teachers, they're both like they're clones of each other, except one teacher gives, they both give an average of C, right? They both give an average of a C. But one teacher gives from a B to a D. So if you haven't hit that kind of teacher, you're going to hit those kind of teachers. They don't think anybody deserves an A, but they don't want to fail anybody outright. So let's say you're at university where D actually is passive. Here it's not, because it doesn't transfer, right? So that teacher gives from a B to a D. The other teacher gives from an A to an F. Is that useful information on top of just knowing that they give an average of a C? Hell yes. If you know you're going to kick ass in that class, which person do you not want to take? Yeah, if they only give up to a B, and you know you're going to kick ass, and they're like, even if God took my class, you get an A minus. Okay. I've had professors like that. Although if you knew you're going to suck in that class, you're going to take the person that never fails anybody. Right?
Yeah.
Okay, so the idea of spread, we're going to talk about next time. 3-3. I'm sorry, what's up? Oh, the quiz, I'm sorry. That's the one we're going to get into. The quiz is on the first part of chapter 2, 2, and 2, 3. Making history.
So that's all.
Yeah, so don't forget next time we get that quiz.